The next topic is registers, and in the registers these are the two important topics. The first one is what is the purpose of register and what are the different type of registers which are commonly found in the computers. Okay, so what exactly are registers? These are very small high speed storage unit which are located inside the CPU. Okay, and we have already covered a chapter on CPU where we have given a brief about the registers, that these are memory units. Okay, and these are not like simple RAM or like hard disk. These are very high speed. Why they need to be high speed? If they are high speed, then only your processing, your function get executed fastly as compared to the other units. Okay, and what exactly is the purpose? They are going to store the instructions, addresses or the data temporarily while the processing. Since they are memory units, they are going to hold something. Okay, and in this particular case, register can store instructions, addresses or data which are to be used during the processing. Okay, and there are many registers which are found in the CPU, and these are the common important CPU register which are commonly asked in the exam, and we are going to see one by one. Okay, so the first one is PC. Okay, so the full form is program counter. Okay, as a word itself suggests that it is going to count the number of instructions. Okay, so basically this program counter register will hold the address of the next instruction to be executed. This is very important. Okay, it is going to hold the address of the next instruction to be executed. And in the instruction cycle, we have seen that there are 4 steps, starting with the fetch, afterward decode, afterward execute, and the final one is store or write back. Okay, and the first the instruction need to be fetched during the fetch phase. That instruction fetching will happen using this program counter. Okay, so the program counter will be having the address of the next instruction to be executed, which is going to be used during the fetching phase. Okay, and after fetching, what it will happen? It will increase the value which is pointing to the next instruction. Let's see the example, that suppose during the fetching phase, before the fetching phase, my program counter is holding the value of 2000. What is 2000? 2000 is the memory address where my instruction is stored. Okay, and after fetching phase, it will be incremented by 2001. Okay, that is the next instruction which is going to be executed. Okay, so program counter is going to store the address of the next instruction to be executed. Okay, so the next one is the instruction register. Okay, so it is similar to the program counter, but it is going to hold the last instruction fetched. Okay, so as we have seen that after fetching, that program counter will be increased by 1, but the current instruction will be stored in the instruction register. That's why it is also known as current instruction registers. Okay, so it is going to hold the address of the instructions which is currently being executed. For example, if the instruction is at 2000 and the instruction is add R1 and R2, this value is going to be stored in CIR. Okay, so let's combine the PC and IR. So as we have seen, if my PC is 2000 during fetching phase, after fetching it will be increased to 2001, and this PC will be stored in the instruction register 2000. It means that this statement, this instruction is executing. Okay, let's see the next register, that is MAR, that is memory address register. Okay, so as a word itself says that this register is going to store the memory address. Okay, and it is going to hold the address of active memory location from which data or instructions to be fetched or data to be written. Okay, it is asked in SSC, HSL and CGL tier 2. Okay, so let's draw it. So this is my register and this is my main memory. Okay, so let's think of it as a 2D. Okay, and suppose let me name it as 1 2 3 4 for the simplicity. Okay, suppose I want to work on this particular memory, the memory number 4. Okay, so it is going to store the value of 4. Okay, suppose I want to access this memory address register will store the location where I need to access this value. Okay, so it act like a pointer means it is going to point to the memory location where my data is stored. Okay, right. For example, if CPU wants data from 500, then 500 will be the value stored in the memory address register. Okay, let's see the next register, that is memory buffer register, MBR or MDR, memory data register. Okay, so whenever you find this word buffer, means it is going to hold the data temporarily. Here in this case, it is going to hold the data or instructions which is fetched from the memory for temporary writing. Okay, suppose I want to do some operation. Okay, and in between I want to store the value of my register in some other register, so I can use memory buffer register in that case. Okay, so if you take the example that if my memory address register is 500 which contain the 500 value. Okay, if my memory address register is 500 and which is going to address some memory location and that memory location contain 25. Okay, so the memory buffer register will have the value of 25. Okay, it is interlinked to each other, but ultimately this is the temporary value which is going to be used during the instruction execution. Next one is accumulator. Again, accumulator will hold the result temporarily and it is basically used in arithmetic and logical operations. Okay, and for example, why I need to add two numbers, 5 plus 3, the sum 8 might be stored in ACC, that is accumulator, for the further processing. Okay, let's take one more example. Suppose this is my expression 5 plus 3 minus 2. Okay, so I want to execute this instruction. Okay, so what accumulator will do? It will accumulate, it will store the value of these two numbers and it is going to store the value in ACC, that is 8. Afterward, again the operation 8 minus 2 will be executed and the result will be displayed as 6. Okay, so in this way accumulator is used. Coming to the stack pointer, as we know that a stack is something which is basically last in first out type of structure where one memory is placed over another. So if my memory location is starting from the bottom 1 2 3 4 5 6 and this represent the stack, so this is the basically the top of stack. This is called TOS, top of the stack, where my data is stored. Okay, this is one of the data structure which is used commonly in the function call, interrupts and the return addresses. Okay, don't go into like computer science engineering field, just remember that it is going to have the topmost value of the memory where my data or address is stored. Okay, and the last one is general purpose register. As the word suggests, it is going to be used for any purpose. Okay, it can be used for storing the data, operand or intermediate results. Okay, for example, There are many general purpose register like R0, R1, R2 are commonly found in the CPU. These are general purpose registers. The next one is the status register or the flag register. So status register or flag register generally store the information about the result of operation. Okay, for example, if there is any zero in it or carry or any sign bit or overflow, all such information is stored in the status register. Okay, if subtraction gives you 0, 0 flag will be set. Okay, and if my result is say negative -5, then this sign status register will be made 1 or it became set. Set means it is going to increase the value 1. If I found that this register is 1, I am going to have that the result is having 0 in it. If my carry bit has 1, it means there is 1 carry. If my sign bit has the value of 1, it means the value inside the register is negative, it has sign in it. Okay, the next one is base and index register, and this register are used in calculating effective memory address. What do you mean by effective? Effective means like if my register is storing say 500 value. Okay, so this is my memory and it is pointing to that 500 memory location. Again, suppose it is having value 100. Okay, so this 100 is not the value or of the data or instruction, it is the address of some other memory location. Okay, so if it is pointing to some other location, that is 100, where you need to access the data. So this is the final destination for which it is to be used. Okay.